Hi, welcome everyone. This is ninth week, and in this week, what we were discussing was all about inner product spaces and basically introduction of inner product spaces. And we did some examples of and exercises about what application of primary decomposition theorem. Okay, so we'll recall little bit about inner product spaces, and then we'll solve simple question, and we will that will be the end. You may ask your doubt in anytime if you wish. Okay, we'll solve questions together. Then that will be very helpful. Okay, so here the definition of inner product in a vector space is defined like this. It is a uh, function from V cross V to F. Okay, or complex number. Yeah, set of complex. Whatever field is taken, V cross V to F. We have this, and this is defined in first coordinate. It is linear, and in first coordinate it is linear means
Your writing is not visible, sir.
my writing is not visible. I think.
I think you haven't shared your screen.
Oh, sorry. Let me say. Sorry, I forgot.
It's okay, sir.
Now it is visible, right?
Yes, sir.
Yes, sir. Now it's visible.
Okay, good. So inner product is defined like this. Okay, it takes pair of vectors and gives uh, a scalar quantity. So okay, there is nothing to say here. Norm is defined like this quantity. Is take plus. If it is plus, it is always positive first of all. In the inner product, it is said like this. This quantity alpha comma alpha. This is greater than zero when alpha is non-zero. Okay, so this is always positive or zero. When zero alpha is zero, then it is zero. So take under root of this, square root of this. Okay, this is called norm. Okay, so here we have a relation of alpha plus beta with norm of alpha plus beta with norm of alpha and norm of beta. So if you square it, now norm square will be this, and at the end we get this equation. Okay, this is similar thing like you have x plus y whole square, right? X square plus y square plus 2ab, something like that. But here we have this real of alpha beta. Okay, okay. So yeah, I'm pointing out only these inequalities or equalities just because these are helpful solving exercises. Okay, so this in particular, which one? This is called polarization identity, from which if norm is given, we can calculate actually what is inner product. Okay, and there is this another thing, parallelogram law. If you remember, alpha plus beta square plus alpha minus beta square. This is equal to 2 norm alpha square plus norm beta square. How you get it? Just look at these two equations. This will give parallelogram. Okay, is there a mistake? No, no, no mistake. This is plus. So remember this. This will be helpful. Oh, here it is written. This is parallelogram and this is polarization identity in compact form. Okay. So here we have some properties about norm. Norm is not actually linear just because of this. You see here, this might not be equal always. Uh, By this is called triangle inequality. Okay, triangle inequality. A triangular inequality. But if you have constant multiplying to alpha, now applying norm, then take that constant norm of the constant outside. But it is not linear. You should remember because of this triangle inequality. This will be helpful. Basically, in real plane, if you see, if this vector is alpha and this is your beta, and what is alpha plus beta? This vector. This is not well drawn, but this inequality says this alpha plus beta is bigger in, sorry, it's less than these two. Okay, when you are going to your college or school, you want to take shortest route, right? So alpha plus beta is the shortest route from this point to this point, and this makes your distance larger. So remember this. This is Cauchy-Schwarz inequality, which says uh, norm of, sorry, modulus of inner product is less than product of norms. Of alpha and beta. Orthogonal vectors, which definition. This is just definition. If alpha and beta are orthogonal, if inner product is zero. Okay. And here we have Gram-Smith orthogonalization process. Okay. You have given a basis, this alpha 1, alpha 2, alpha k. Now you can construct another basis, beta 1, beta 2, beta k, such that, no, no, beta 1, beta 2, beta n given. Now you can construct alpha 1, alpha 2, alpha n. This, here we have k, right? K. Everywhere it is k, okay? So they are orthogonal basis basically. Any basis can be transformed into another basis, which is orthogonal basis. Okay, orthogonal basis means every vectors they are orthogonal to each other. Okay, so, so remember this formula. Uh, for time being, you will understand what is going on here. Okay, once you have a basis vector, let's say beta 1, another basis vector, let's say it is beta 2. So how alpha 2 is constructed? Okay, alpha 1 is taken to be beta 1 and alpha 2 is constructed from beta 1. This is your beta 1 and beta 2. How? You just get a projection here, projection point here, projection of beta 2 on beta 1, and then you consider, now you have this projection. Let's say this vector, I'm writing this vector like, let's say uh, x. You just take alpha to be x. This projection vector, how you calculate it? How to project beta 2 on beta 1 onto beta 1. Sorry, beta 2 projecting onto b2 b1 beta 1. It's this norm of beta 1 square into beta 1. Okay, this is your this point. Now what you do? to find x. X is nothing but beta 2 minus this vector. Now you have this vector, this point, beta 2 minus this. No, yeah, minus of this first, then plus of beta 2. Something like that. Here we have beta 2 minus. So it will be either plus x or minus x, I don't know. But this is the formula, right? Here. Okay. This is for alpha 2. So we'll calculate this in a question. Okay. Okay, this is your first question. Let me see your attendance. Oh, sorry. My internet is gone. Hello. Hey guys. My internet is bad today. Hello.
आवाज नहीं आ रही है सर। आवाज नहीं आ रही है आपकी।
ओह, हाय। अभी आ रही है?
हाँ अब आ रही है।
ओह, थैंक यू। सॉरी यार। सॉरी।
गांव गए क्या सर?
No, no. I got a new LAN cable and it is not working. I'm in my institute.
ओह, ओके ओके ओके।
So let us start now. Sorry for your miss. Okay. So we are looking at first question. So if V is R4, vector space for R, T is a linear operator on V, and there is an element alpha in V which satisfies Ft, okay, where F is this polynomial, and this is the smallest degree polynomial. Okay. So this will become a characteristic polynomial, right? Because R4 has got dimension 4 and something which which is monic irreducible and
Screen, screen, your screen is not visible. Please share your screen.
Screen last, yes.
oh, sorry.
Please share your screen.
Now it is visible, right?
Oh, okay. Yes, useful.
Okay. So Ft is the smallest degree polynomial and it is 4-degree polynomial, which only no less degree polynomial satisfies alpha. So this would be characteristic polynomial for T. Okay? And if you see here, alpha, T square alpha, T cube alpha, this all will be form a basis, ordered basis. This ordered basis. This is another basis as you have seen. So what they are asking is what is matrix representation. So because this is an okay, this is not given that is irreducible polynomial, but assume that it is irreducible form, irreducible polynomial. But then what we have characteristic polynomial. Sorry, I forgot. Rational canonical form. Rational canonical form. Can you answer it? What it should be? This would be first, right? No, no, no. Minus one, and then what happens? Let's see here. If you apply t on first basis element, this becomes t alpha. Okay, 0 into alpha plus 1 into t alpha plus 0 into t square alpha plus 0 into t cube alpha. If you apply t on second basis element, which is t alpha, what you get? T square alpha. It says 0 alpha plus 0 t alpha plus 1 t square alpha plus 0 t cube alpha. Okay, so if you see here what is happening, first column will be 0 1 0 0. Second column will be 0 0 1 0. Third column similarly because of t cube, t square of it becomes t cube. This is third basis element 0 0 0 1 here. Now what happens to last column? So calculate it t cube alpha. What is t? This becomes t power 4 alpha. But t power 4 alpha is same as, because ft is alpha is 0. So t power 4 plus t cube plus 2 t square plus t plus I acting on alpha is 0 acting on alpha. So this will imply t power 4 alpha is same as minus of t cube alpha minus of 2 t square alpha minus t alpha minus I alpha means just alpha. Now what it is? First basis element minus 1 into alpha. Second,
Yes, visible, sir.
sorry, internet is getting
O-
bad.
Okay.
Okay. So minus 1 into t alpha. This is second t alpha second basis element. So what we get in the column minus 1, fourth column minus 1 minus 1 minus 2 t square alpha. This is third basis element. So we get minus 2 in third base and then minus of t cube alpha. Okay. So this we get minus 1 again. So this the option is correct. Okay. You understood, right? Rational canonical form. Writing rational canonical form is very easy. So in the below the diagonal, you write 1 everywhere, okay, like this. And in the last column, what you write? Minus of this coordinate. Then minus of this place. Minus of 2 here, third place. Minus of 1 again. Like this. Okay, so I suppose this was easy. Did this and solve this. What about this? Your vector space's dimension are. Okay. Okay. So you have minimal polynomial factoring like this. So this is also characteristic polynomial. See, this is also 8-degree polynomial. So for this 4, eigenvalue 4, we get 2 cross 2 block like this, Jordan canonical block. Because minimal polynomial has got degree 2 here, so we got 2 cross 2 and block like this. And for this we get rational canonical form, where we get 0 0 0 1 0 0 0 0 1 0. I'm writing rational canonical form. Okay, 0 0 0 1. In the last column you should get -1 9, because of this, -3, and then again -9, and then -4. This is your block corresponding to this factor. Okay, this is irreducible decomposition, I suppose, because we cannot factor into linear factor like that over real number, or we can. But anyway, given any polynomial, you can write a canonical, rational canonical form like this. So this form will be only last two option we have to check, because these are
C is correct.
is correct. Okay. Yes, we have to check about x square plus 1. Now, what will be the rational canonical form for x square plus 1? -1 and 0 in the second word. Right? Okay. Because x square plus 1 is written like x square plus 0x plus 1. So while writing rational canonical form, this will give -1 here, and this will give 0 here. So C option is correct. Before internet goes away, let me solve next question. V is R4, okay, and T is defined like this, and alpha is this vector 1 0 1 0. Define the subspace Z alpha T, which is defined to be Ft alpha, where alpha F is varying. So if you see this is nothing but a span of alpha, T alpha, T square alpha, and so on, right? Right? Because every Ft alpha, I'm saying Ft alpha can be written as Ft is a polynomial, so it can be written like a t power r plus ar t power r plus a0. Now applying to alpha, you get a ar t power r alpha. Now see, this can be written as linear combination of these things. Okay. Okay. So we just look at these elements. If they got repetition, then that will be the end. Let's see, 1 0 1 0 1. Apply to it. This is your alpha t. This goes to x1 plus x2 means 1 0. X2 plus x3 means again 1. Okay. Look at t. Then x3 plus x4, that is also 1. Now we got x1 plus x4, that is also 1. Now this is your t alpha. Apply t once more. T. What we get? 2 2 2 2. T square alpha is this, and this belongs to span by T alpha subspace. Do you understand? We got only two vectors in this set. We got span 1 0 1 0 and 1 1 1 1. Now, if you apply T for higher degree many times, every time it comes inside T alpha, right? What is dimension of Z alpha T? Am I audible?
Yes, sir.
Okay. What is answer for this? First of all, you understood this, that Z alpha T is nothing but a if, uh, span of Ti, uh, I belonging to natural number union 0. Okay. Now we got in this particular case, this is the all T power I alphas. They are nothing but multiple of 1111. Right? This this implies T power I belongs to T alpha is subspace generated by T alpha for every I bigger than 1. For every I bigger than, so we get this set is nothing but alpha T alpha, and alpha and T alpha are linearly independent. Obviously it is, and 1 0 1 0, and second is 1 1 1 1. These two are linearly independent. All others are depending on 1 1 1 1. So dimension is 2. That alpha got dimension. If you have doubt, you can ask me. Otherwise, I will continue. Going to next question. Okay. Suppose you understood this. It's the fourth one. Which of the following are inner product corresponding vector space?
Sir, last question. T square alpha means?
T square alpha means T applying on T alpha. So T alpha you have 1 1 1 1. Now you apply T on it, you will get 2 2 2 2. Right? Because what T does, T adds these things. This is going to first coordinate, this is second coordinate, this is third coordinate, this is fourth coordinate. So every time you will get 2 2 2 2 here. Now if you T cube alpha you calculate, that will be 4 4 4 4, and that will be the multiple of T alpha only, right? This argument in the bracket, this implies so. I think you understood this, right? Okay, so going to next question. Okay, I think you understood it. Which of the following are inner product? So what happens to first? What can you say about this? Want to try? Then waiting for a minute. is false. What is reason for this? Take alpha is equal to I, every coordinate is just I. Then alpha with alpha, what will be this? I into I first, then I into I again, n times. So this will become minus n. It is not positive. So B is false. What about A? Is also false. For example, take n is equal to 2. Okay, take this matrix 0, 0, 1, 0. Okay, then again take this is your alpha. Now alpha with alpha inner product will be 0 into bnn is 2 2 1 plus a22, which is 1. This is your 1. What is b11? B11 is now 0 because alpha and beta is also beta. Then I'm writing alpha beta with the formula above. Okay? So this becomes 0, but this is not greater than 0. We want alpha comma alpha inner product when alpha is non-zero, it should be strictly positive. So that's why it is wrong. Okay?
Inner product should be positive.
Yes, positive definite means inner product if alpha is non-zero, so inner product of alpha with alpha should be strictly positive so that it gets a norm. When you take under root, you get a norm for alpha. It's length of alpha. In that sense. What about C? Polynomial of degree at most 4. Inner product is defined like this. This was proved in the class that it is inner product, right? Because integration is linear. F1 plus F2 into G into means inner product. This is equal to 0 to 1. F1 plus F2 into G dx. This will become F1 of F1G dx 0 to 1. I'm missing x here, okay? Notation problem. That's what. Plus this is equal to 0 F2G dx. So because integration is linear, so we can write F1G plus 2. This is symmetry because Fg to take integration of Fg dx 0 to 1. This is same as Gf dx 0 to 1. So this is symmetric. You can check all that this satisfies all the properties. What about F intersects, sorry, F with F? This will be positive. Why? Because this becomes F square function, Fx square, F square. F square is a positive function, okay? The positive function gets integration positive. You understood this from analysis, okay? I'm just verifying. And one more thing was missing. This, I think all the properties. Now C, if you multiply C inside first coordinate, it will go out of integration because integration is linear. So all the properties it satisfies. So C is correct. What about V equal to R2, and this is the definition. Is it symmetric, or I'm taking option D? This was for it is linear, that you understood, right? Alpha 1 plus alpha 2 beta. This will become, let me write notation first. Alpha 1 is equal to x1 y1, alpha 2 is equal to x2 y2, and beta is equal to xy. Then alpha 1 plus alpha 2 is x1 plus x2, comma y1 plus y2, comma x comma y. The product of this, and this will become x1 and y1. Means x1 is now first coordinate is this plus y. Y1 is this x, and all other coordinates. I'm leaving that. Okay. Similar thing. So this will become x1 into x plus 2 x. Now you see here integration of x1 y1 with xy plus integration x2 y2 with x. You just check it, huh? Not checking it. You just take this coordinates. This will give this where x2 appears. And then okay, so I think this is symmetric by itself. If you replace x1 by y1, x2 by y2, this equation is nothing to change. Okay, this equation remain itself. This will go to this and this will go to this, but they are same. If you calculate, this is alpha beta, and but beta alpha is also same thing. These are all real. So conjugate symmetric, we are not talking about conjugate symmetry. Just symmetry will work because in the definition, sir was given give like conjugate symmetric. Look at third condition. Beta alpha is equal to alpha beta bar, but bar is nothing here. For real numbers, x bar is equal to x. So we are just looking for symmetricity. Okay. Am I audible?
Yes, sir.
Okay, so let me do fast because internet is
Yes, sir.
bad. This is also inner product. You just check it. All the property it satisfies. Okay. Okay. Here we have minus things, huh? So we should check that special property that alpha inner product with alpha should be positive. That is mandatory to check. Okay. Everything else is formal. Just follow your nose. So alpha with alpha, it should be positive. That is what the property we should check at least. So let xy inner product with xy, what it will be? It will be x into x. Okay. 1 y1 minus x2 y1. Minus x2 y1. x2 is this, y1 is minus xy, and then minus of yx. Okay. Okay. And next, one more term left, x2 y2 means y into y plus 7 y into y. This is equal to x square minus 2xy plus 7 y square. But you see here x minus y square plus 6y square. And these two are real numbers squares, and we are taking plus. So this will be positive. Okay. Either x is non-zero or y is non-zero, then it is non-zero. Once it is strictly positive, in fact. Okay. So this was needed to check. So I suppose this is also done. Let's see next question. Consider the inner product space V, where we have alpha, beta in V, and these things. Use parallelogram identity to find V. But it will be beta norm beta square plus norm alpha square 2. This will be equal to norm alpha plus beta square plus norm alpha minus beta square. Alpha plus beta square, it means 4 square. Alpha minus beta is given 2 square. Alpha is given, so 3 into 3 is 9. Plus beta square, we want to calculate beta. So let it be written like this. So this is 18 plus 2 beta square equal to 16 plus 4. This is 20. So 2 into beta square becomes 2. Beta square becomes 1. This implies norm beta becomes, because norm is always positive, so this becomes just 1. Okay? Square root of 1 is 1. This is easy. If you remember parallelogram identity, it is easy. Okay, this is just calculation, nothing to mention. So let's see next question. I'm doing it fast today because my internet is very bad. For any integer inner product space B, alpha beta belonging to B, so plus beta is given alpha minus beta. Okay, they want to calculate inner product of alpha beta. Now you remember polarization identity. Polarization identity. In the compact form, it was easy, if you remember. It was summation non plus e power n beta n from 1 to 4, right? And there was this another thing, I power 4, sorry, I power n by 4, right? This was alpha beta. It was not, let's see, it is given above. So we were missing this square, okay, in the polarization. Norm is square, everything else is square here. Now write everything, it becomes for n is equal to 1, is this correct? Equal to 1. I was thinking 0 to 3. What it is, I by 4 on alpha plus I beta square plus minus 1 by 4 on alpha minus beta square plus minus I cube means minus I plus I by 4 or minus I beta square plus I power 4 is just 1 by 4 on alpha plus beta square. Okay, so now put everything. We have all the values here. Alpha plus beta is just I by 2 square by 4 minus alpha minus beta is 3 by 2 plus I by 4. Alpha minus I beta is 6. No,
4.
4 square, yes. Plus 1 by 4. Alpha plus beta is 5 by 2.
6.
What's the mistake here? Because this was alpha plus I beta, I should write here 6 square. Here we should write 5 by 2 square. Right? Now everything is easy. This is 6. 36 by 4 is 9I. Yes. This is 9 by 16 minus, here we have I. 1 4 get cancelled and it becomes 4 plus 25 by 16. Now what it is? It is 16 by 16 because 25 minus 9. 16 by 16 is plus and then minus of uh,
5 by 4.
9 plus here we have I by 4
Plus
means
35 by 4 I.
35 by 4, right? So we are not matching our answer, but I think this is incorrect. Oh, I remember this question is itself incorrect. Okay, this question is wrong. So we are not going to solve this. But this question is wrong. If you point here, okay, let's say alpha plus beta, mod alpha plus beta square. This is nothing but normal. Sorry, so the question was correct, but but uh, there was an incorrect calculation here, calculation mistake. Because of that, we are not matching our answer. But now it is matching. From polarization identity, we got this inner product alpha beta equal to 1 plus 5I, and which is matching with option B. Okay, so let's see next question. Question number 7. These are 3 and alpha beta are given like this. What is relation between XYZ? XYZ satisfies some of these identity. Which one? Oh no. In this question, there is this mistake. Modulus. Okay. Now, there was a property Cauchy inequality of norm. What it says? Norm of less than or equal to norm of alpha into norm of beta. What is norm of alpha here? This is under root 8 square plus 9 square plus 12 square into what is norm of beta? Norm of beta is given to be 2. This 64 plus 81 plus 144. So this is 4489 448 2 289 into 7. Sorry, 2. So this is 17. 17 square is 289. This is 34. Okay. This side we are getting 34 and this side alpha inner product with beta. This we get norm 8x plus 9y plus 12z. So first option is correct. Okay. Okay. This is how this inequalities are helpful. One is very bad and opt out again.
It's not audible, sir.
Sorry, because of internet, I was locked out. Okay, I'm coming to seventh question. Seventh question was easy. You remember this Cauchy inequality, which was given like this: mod of inner product.
Please share your screen, sir.
Oh, okay. Let me share. I shared, but because of internet, it is not. Shared. Are you audible now?
It's audible, sir, but the screen not seen.
Okay. Wait a minute. I'm sharing my screen. Is it visible now? I think it is. So, seventh question was easy. If you remember Cauchy inequality,
We can see the screen, but we're not able to hear the voice.
so sad. Okay. So
Now, okay, sir.
let's say everyone understood 7th question. There is nothing. It is just cos inequality. If you remember this particular line, you can solve it. Okay? Anyway,
Sir, good evening, sir. Good evening, sir. Can you please explain how 8x plus 9y plus 12z becomes 24z, sir? You have written the A option is correct, no?
yes.
But it is 8x plus 9y plus 12z only, no?
Oh, sorry.
How
Then
it is, no?
all the options are incorrect.
Uh,
So
But there is 24. There is
yes,
need to be
yes, all the options are incorrect. It should be, if it is 24, then only it matches, right?
if it is 24 also, the value of this only will change, no? Norm alpha.
Oh, sad. Yeah. So this question is a mistake. I said initially, I think there was some question mistake, but here it was not in this, but here it is. In this question, there is typographical mistake. So I'm leaving this. But anyway, you understood, right? So
yes, sir. Concept is clear.
yes, this is the only thing they are asking. If you remember cos inequality, then it is fine. So let's see question number 8. B is R2. Vector space is R2 equipped with this kind of inner product. Then minus yx is orthogonal to xy provided which condition is satisfied. How to see it? So when they are orthogonal, minus yx, if the inner product is 0, xy, right? Inner product of these two vectors is 0. Orthogonal implies this. Orthogonality of these two vectors will imply inner product is 0. But what is inner product? From this formula, if you say minus y x minus x2 is x y1 is x. Look here, this is y1, this is y2, this is x1, this is x2. So x1 means minus y1, y2 means y plus 4, x2 y2 means xy is equal to 0. But what it is, this is plus y square, sorry, this is y, na? y2 is this, y2 is y2, sorry, y is coming, y2 is just y1 just, it is also y, because here we have x1 and in place of x1 we have minus y, right? Okay, so this is y square minus x square plus 3xy equal to 0. So divide,
Minus y square, sir.
no, we have minus y inside. Let me rewrite it. What is x1 minus y1 minus y, sorry, what is y1, this is your x, this is y1, this is y2, this is 1.
Okay, sir.
This,
Okay, sir. Correct.
yeah, so from the formula
You
you
can
got
proceed,
this.
sir.
Okay, so divide by x square, you get y by x square plus 3x by 3y by x minus 1 is equal to 0. Okay, now you apply to get roots of this quadratic polynomial. This is nothing but p square plus 3p minus 1. So you get roots of this minus 3 plus minus under root b square minus 4ac. B square means 3 square means 9. Minus b square minus 4ac. Minus 4ac मतलब p is minus 2a means just 2. This will imply that y by x is equal to minus 3 plus minus under root 13 Okay, so we got a quadratic polynomial like this, and we will find out roots of this. Roots we are getting minus 3 plus minus under root 13 divided by 2. So from here what we get, x is equal to, sorry, we want x in terms of y. So we should divide by y. That will be very good. From here we are changing the paths. We want x in terms of y. So divide by y square. Then you get minus x by y square plus 3 x by y plus 1 is equal to 0. Write it like this: x by y square minus 3 x by y minus 1 is what we want x in terms of y. So I'm just changing my path from this step. Let it be incorrect, but it is correct. Okay, because answer is not matching, that is why I'm going changing the path from this step to like this. We are dividing by y square now. Okay, from here we get x by y is equal to minus 3 minus b plus minus b square minus 4ac minus 4ac divided by 2a. But minus b is what? 3 plus minus b square 9 minus 4ac, we get plus 4. So c is 1, a is 1, is minus 1. 2a means just 2. So from here what we get, x is equal to 3 plus minus under root 13 by 2 y. Okay, so which option is correct? From here you can see third option is. So this is also a calculation. So if you missed something, you look into this PDF that will be available. This is so easy. Once you understood that two vectors are orthogonal, then inner product is, that will give the condition which is required condition. Okay. So let's see next question. So let's see ninth question. In the eighth question, there was basically that was so easy that if two vectors are orthogonal, just apply the orthogonality condition so that inner product is zero. That will give you required solution. Okay. So let's see next question. Okay, next question. What is V is R3 and we are given a basis of V and we want to calculate orthogonal basis using Graham-Smith.
ఈ రోజు క్లాస్ అంతా సార్ది ఆగిపోతుంది.
What?
నెట్వర్క్ ప్రాబ్లం అనుకుంటాను, ఆగిపోతుంది. తన్విశ్రీ భోంచేసాం.
Oh, sorry. It's not audible. Sorry. You are audible, but internet is bad. I don't know what is happening today.
సారీ.
So this is last question. After this, today session will be end because of the internet problem.
It's not audible, sir.
I'm saying after this question, this is last question for me today. We'll see tomorrow. Last question means ninth question is last question today because of this internet issue that cannot.
Okay, sir. You upload all your writings, sir.
Yeah. I will upload the video which will contain the last question also. Okay. So okay, V is given R3 and we have given a basis of R. Okay. Now we want an orthogonal basis for R3 using Graham-Smith orthogonalization process. So they are asking what is beta 2. So for alpha 1, you remember it is just beta 1 is just alpha 1. Sorry, alpha 1 is just no. Here in the definition, but anyway, this is not matching. But what is beta 1 is just 1, 2, 0. Okay. How to calculate beta 2? Beta 2 is nothing but alpha 8, 1, 6 minus inner product. This 8 minus 1, sorry, plus 1 minus 6 with first means alpha 1, 1, 2, and in this direction, 1, 2, 0 direction. 2 divided by mod 1, 2, 0 square. Let's calculate it. 8, 1 minus 6 minus this is 8 into 1 plus 1 into 2 minus 6 into 0. 1 square plus 2 square.
Please share your screen, sir.
Okay, let me share it. At least one question you see. Is this visible now?
Yes, sir.
Okay, good. So how to calculate beta 2? Basically from the second you subtract. If this was your beta 1, somewhere you have second basis vector, let's say 8, 1 minus 6. You just project it and From the second, you just subtract this. You get this perpendicular vector. So that is how orthogonalization process was defined. So projecting 8 1 minus 6 in this direction 1 2 0 is this inner product. In this direction means you have to multiply by 1 to 0 and divided by this norm of 1 to 0 is square. So norm of 1 2 was under root 1 square plus 2 square, but because of this square we are not writing under root. So 8 1 minus 6 minus this is 8 plus 2 means 10 5, this is 5 1 2 0, and you just need to calculate it now. This is just 2, okay, this is 2. So let me write in next is 8 1 minus 6, and now multiply by 2 inside. This is minus 2, sorry, plus 2 plus 4 0. Now it is 8 plus 2 is 10, 1 plus 5 plus 2 because of this minus. 8 minus 2, 1 minus 4 minus 6 minus 0, and you get 6 minus 3 6. So you get this C option correct. Okay. So actually, na, am I audible? I'm ending my class today. Video 10-minute extra video will be attached to this. Bye bye everyone. The last question was all about Graham Smith.
Hello.
Hello.
Sir?
Yes.
Uh,
I'm saying last question is just about Graham Smith orthogonalization process. So I'm doing it, but because of internet problem, you can leave. Okay. So happy Oli.
Sir?
What you want to ask?
happy Holi, sir.
Yeah, yeah,
Sir,
happy.
you upload as early as possible, sir.
Correct, correct. In 10 minutes or 20 minutes, it will be uploaded. Because of this internet issue, I'm suffering very much. Okay, let's see next question. These see, in is with this standard linear product. If this is a basis of R3, so look into this thing 120860001. They want to calculate beta 3. Okay, now you say what you get beta 1 2 0. What you get as beta 2 6 6 minus 3 minus 6 from this question. It's ninth. Now you want to calculate beta 3. Let's write a formula for this. Beta 3 is equal to 0 0 1 minus 0 0 1 inner product with 1 2 0 in the direction of 1 2 0 divided by norm 1, 2, 0 minus now the same vector 0, 0, 1 projection along the second. You got 6 minus 3 minus 6. Second orthogonal vector divided by norm of 6 minus 3 minus 6 square in this direction. 6 minus 3 minus 6. Okay, 0, 0, 1 minus you got this inner product is 0. A standard product. This whole quantity becomes 0 because 0 into something becomes 0. So no need to write it back. So in this case, you get inner product equal to minus 6, 6 square plus 3 square plus 6 square. 6 minus 3 minus 6. This is 0, 0, 1 minus minus becomes plus here plus 6 by 6 square 36 36 plus 9 81 6 plus 3 minus 6, but it is 27. So you get take minus 3 common once more or 3 common and it becomes 0, 0, 1 plus 2 9. Here you have 2 1 plus 2. Okay. Now row 0 9 plus 4 minus 2 4 total 1 by 9 outside. So this is 9 4 2 5 by 9. This is first option. So we got first option is correct. So today my internet was bad, that's why without guys it was it. Sorry for this. That's then. Bye. See you next week.